Today we're going to discuss the calculations of the lab we did where we heated Mg and NaHCO3, which is baking soda, and observing the reaction change, the change in their masses as they reacted. What you should have found with your data is that the magnesium actually increased in mass when you heated it up. So you should have noticed that the grams of the crucible, of course, went up when you put in the magnesium, but then after you heated it, the mass at the end was actually larger than what with which you started. So what we need to do is we need to find out the grams of the magnesium as well as the grams of the product. Our goal is to realize that the magnesium reacted with oxygen in the air. So it grabbed oxygen from the air and made a compound with magnesium and oxygen. We're going to find two things, the percent of magnesium and oxygen as well as the formula of the magnesium and the oxygen. When you deal with percents, you're always going to use grams, and when you deal with formulas, you're always going to deal with moles. So a formula is a molar ratio. For instance, if you have H2O, that's going to be a 2-to-1 ratio of moles of hydrogen to oxygen. So we're going to start with the grams first. We want to find the grams of magnesium in the product. Well, the grams of the magnesium in the product are the same as the grams of the magnesium in the reactants. So we're going to subtract these two numbers to find out the mass of magnesium. So 17.556 in our sample data minus 17.821 is going to give us, well, I should have done it the other way around, of course, but it's 0.265. 0.265 grams. That's going to be the grams of magnesium. So to show the work for that, we'll write over here 17.821 grams. That's going to be the crucible plus magnesium minus 17.556 from our sample data grams, which is just the crucible. That's going to give you the mass of just the magnesium, which came out to be 0.265. Okay, so now what we want to do is we want to find the grams of the product. Well, the product was at the end of the lab. So at the end of the lab, we had 17.990. Of course, if we subtract the crucible from that, we're going to get the product. So 17.990 minus 17.556 gives you 0.434 as the product. So we'll write our work over here, 17.990 grams minus 17.556 grams. The first one was the crucible plus the product, and then we just subtract the crucible by itself. So now we're going to have just the grams of the product, and that comes out to be 0.434 grams. So now what we're going to do is just find the grams of the oxygen by itself. Well, the oxygen by itself is the difference between the product and the magnesium. So you put the product over here, which weighs more than just the magnesium, of course, because the product has magnesium and oxygen. So you're going to take 0.434 grams of product minus 0.265 grams of magnesium. And when you do that math, you're going to get an answer of 0.169 grams of just plain oxygen. Now to get a percent, remember what percents are. We'll do that later actually. Oh, I guess I forgot to put that on here. All right, well we're going to learn how to do that and then we'll do the moles. I should have put this on the paper. Let's find the percent of each, the percent of magnesium and the percent of oxygen. And what I'll do is I'll fix the notes so that you have it on your copy, but it's not going to be on this copy right here. So the percent of magnesium is always going to be part over the whole for percent. So the magnesium was 0.265 grams of magnesium divided by the whole product was 0.434 grams of product times 100. That's going to give you 0.265 divided by 0.434 times 100 gives you 61.1% magnesium. And then to do the oxygen, you would do 0.169 grams of oxygen divided by the total product again, which was 0.434. Times 100, and that's going to give you an answer of 38.9, which you could do in your head because they have to add up to 100%. So that's the percent of oxygen in the product. Okay, now we're going to deal with finding moles. So we learned how to do a mole conversion. So for magnesium, it's going to be 0.265 grams of magnesium. You want to get out of grams, it goes on the bottom. You want to go to moles, it goes on the top. You're going to use the periodic table. This weighs 24.3 grams. So 0.265 divided by 24.3 is going to give you 0.0109. 109. And I'll do this just in purple to remind us that this is going to be moles. Sorry about that. I'll do it over again real quick. So the 0.265 is the grams of magnesium. We're going to get rid of grams and go to moles. It weighs 24.3. So the moles is 0.0109 moles of Mg. Now we're going to get to the moles of oxygen. It was 0.169 was the grams. Now I'm going to convert that into moles. This weighs 16.0 grams per mole. Notice I'm not using O2. O2 is only when it's by itself, but it's not by itself right now. It's in a compound, so you don't have to do it at 32. So it's 0.169 divided by 16. That's going to be 0.0106 moles of O. So now what we want is a simple ratio of these two. So you would divide by the smallest one. The smallest one is 0.106. So 0.106, and that's going to equal, basically rounded, a 1-to-1 ratio. So if it's a 1-to-1 ratio, 1-to-1, that means the formula must be, in our example, MgO. Now in your data, which you're going to do the calculation in a minute, you might not get a 1-to-1. You might get a 1-to-2. Whatever you get, you get. Okay, but we're just going to take the nearest whole number. So if this is like a 1.1, it's still 1-to-1. If it's a 1.9, it's like a 2-to-1. So just take the best ratio with your data.